Okay, thank you, Alexander, for your introduction. This is Dijk speaking. I will give a brief presentation on the activities under the CEN TC89 Committee on the Thermal Performance of Buildings and Building Components. Let me see if this works. Yeah, this works. So I'll first start with a brief look back to the 80s actually. What did we do in the 80s? We developed standards on the building envelope and components. So for instance, standards on thermal insulation, air tightness, and so on. So typically the component approach. Then in the 90s, we switched to standards dealing with building heating needs, which means we wanted to include, for instance, passive solar gains. Then 10 years later, we saw the first standards on energy use for heating and cooling, which means that we introduced elements like the efficiency of the boilers, but also the cooling needs and the cooling use. Then we are now dealing with more complexity. So we're dealing now with the overall building energy performance, which means we include also things like lighting, controls, and domestic hot water. So we see more and more interactions between all these elements in the energy performance of buildings, and this might also lead to a reconsideration of the methods we use to calculate the energy needs for heating and cooling, which is the main topic of my presentation. And of course, we're also looking forward to standards which deal with energy producing built environment. So from components to the overall energy performance is the main trend. I'm coming back to one of the slides that Jaap already presented as the cooperation between CEN and ISO, and I have a particular reason for that. I'll show you in a minute. So in CEN, the work is coordinated by the CEN TC371, as you know. This committee is closely collaborating with the ISO Joint Working Group on the same issue, and I happen to be one of the two co-conveners of this ISO Joint Working Group. A joint working group of two ISO committees, TC163, TC205. And TC163 is closely collaborating with the CEN TC89, and that's the main topic, the main reason why I show this slide, because we're dealing here with the CEN TC89 standards. And to make the picture complete, although it's still a simplified picture, of course, ISO TC205 is closely collaborating with ASHRAE, so we have a very relevant input from ASHRAE there as well. So again, TC89, TC163 cooperation is the main issue for my presentation. So the work program for TC89 in collaboration with ISO contains 4 clusters. Cluster 1 is dealing with climatic data, which mainly is about the conversion of the solar radiation and the shading effects on different building envelope elements. So that's one standard. Then cluster 2 contains of 5 different standards, which cover the ways to express the energy performance and energy performance requirements, both on the overall level, so the holistic overarching level, but also on the building and building fabric level, 2 different standards. And then the calculation of indoor temperature and energy needs for heating and cooling. I'll come back to that one later. And cluster 3 is on hygrothermal performance of building components and building elements, so mainly thermal resistance and U value and so on of roofs, walls, floor, windows, and so. Then cluster 4 deals with the thermal, solar, and daylight properties of windows and facades. And at the right hand of this slide, you see a number of ISO numbers. In the ISO Joint Working Group, we created a systematic list of ISO numbers to be prepared for the future, for the collaboration between CEN and ISO. So all the standards which are now more or less new will already get these new ISO numbers, and you see the red ones here, which are now being reserved for the work we are doing at this moment. So about calculation of energy needs for heating and cooling, this is covered in the ISSO 13790 standard from 2008. That standard contains a monthly method. Monthly means that you use monthly mean values for all the inputs. So a monthly mean thermal balance of your building. And in order to take into account the dynamic effects of daily behavior and so on, we use predetermined correlation factors. Then, in addition to that, we have in the same standard a simple hourly method, which does an hourly calculation, but very simplified by lumping all the construction elements into a few thermal resistances and some mean thermal capacity. Detailed simulation tools are also mentioned in the standard, but are not fully described there. So what will be revised? So the main thing is that we will develop a new simple hourly method, and I'll come back to that, the details of that later. So why still a simplified hourly method? Why not the detailed one? That's because we need a balance in the calculation procedures, because they need to be transparent, robust, reproducible, and verifiable, and also affordable and reliable with respect to the acquiring the input data. And that's because the method has to be applicable for the national building regulations, so to set minimum energy performance requirements, energy performance label, and so. On the other hand, why then not stick to a simple monthly method, why an hourly calculation? And that's because, as I said before, we need to deal with the dynamic interactions. And with the monthly method, you have these correlation factors to take into account, the dynamic effects, but if it becomes more and more, the physics become more and more complex with the new technologies, the actual hourly calculation is much more robust, transparent, and easier and reliable. So that's the main reason for working out a revised simple hourly method. So it's not the aim to increase the overall accuracy of the method to compete with a detailed simulation tool, but mainly for these hourly patterns. So as an illustration, I have this slide. So if you want to use a monthly method, you need monthly mean values, and that can be problematic. For instance, see if it comes. Yeah, internal gains, they can be different between weekdays and weekend days. Mechanical ventilation, the same. Solar blinds down could be quite different between weekdays and weekend days in an office, for instance. And here you see already the difficulty if you take the mean values of all these things. Also, the cooling set point will be different. Free cooling by extra ventilation also. So. And there are many more of similar things which I could show which have the same problem. So the main difference with the current simplified hourly method is that the simplified hourly method which we have now at the moment from 2008, as I said, all the construction elements are combined in just a few overall resistances for the window and for opaque elements, and one overall capacity. So you need still some correlation factors and fuzzy factors to get something which is more or less realistic. And if you look at the new simplified hourly method, we are working on it this moment, because we know each construction element anyway, that is the input for the calculation. So we keep these elements separate in the calculation. So the windows, the walls, the roof, and the floor, each can have their own thermal capacity category, whether it's light or heavy. Each one can have their own conditions at the other side, so whether it's outdoor air or is the ground, which is a very important element, whether it's adjacent heated space, and each can have their own solar absorption factor. So for instance, for a large roof, that's also important. And again, no extra input data is needed for the user. So we have a lot of advantages compared to the current method. And this brings me to the last slide. So what is the what is the plan concerning the setup of these standards. So we have an ISO standard, ISO standard 13791, which gives a generic hourly calculation method for the thermal balance in a building or building zone. We want to use that, so to revise it, and that will be the standard 52017 part 1. And we use this generic hourly calculation method as a basis to develop the new simplified hourly method for the calculation of the energy needs for heating and cooling in the standard 52016 part 1, which will be the successor of the 13790. It will be based on this generic method, but with very specific assumptions for the calculation if you want to do it for the energy needs for heating and cooling. And the same standard will also contain still a monthly method for the calculation of energy needs for heating and cooling. And for the monthly method, you need these national correlation factors to take into account the dynamic effects. And what we have in mind is that this hourly calculation method will produce extra output in the form of monthly characteristics for your case, which can be used as a basis to generate the correlation factors for the monthly method. So there you will have a link between this simplified hourly method and the national correlation factor. And in effect, you'll have a link between the generic hourly calculation method, the simplified hourly calculation method, and the national and the monthly method with the national correlation factors. And on top of that, and that's the last one, which is currently being discussed here in the CEN teams, is would it be possible to do the calculation of the cooling load also using as much as possible the same simplified hourly method? And of course, you need adapted assumptions for that as well. So that will be something for the next months to see. And that brings me to the end of my presentation.